I'll check though. Okay, so continuing on with chapter 5. Today we're going to talk about inverse functions. This one gets a little nasty, but I'll show you a couple tricks. We'll get to a point where we're going to be looking for the derivative of the inverse function, and I'll show you two different approaches to it. One is formula-based, the other one is geometric-based, and of course, I'm always going to opt for the geometric approach, but you can use either one. Okay, so you should be able to talk about a function being an inverse, whether or not two functions are inverses of each other. Not all functions have inverse functions. I shouldn't say that. All functions have inverses. The question is whether or not their inverse is also a function. We'll talk about that. We're going to find the derivative of the inverse function, and then you can just give up on your how many people made New Year's resolutions? Be honest.
I forgot.
No one did? Excellent. They're dumb anyways. You never stick to them. But it's really rough finding a treadmill at the health club now because everybody and their mother wants to get healthy after the first year. The good thing is you don't have to wait for a lot of those people. They're good for like 5 minutes and then they're gone. Okay, so a little bit of review here and some notation. I don't know if you've seen this before in pre-calc, the inverse notation. Have you seen that before? Okay, so f is the function. F to the negative 1 is the inverse function. Not the reciprocal function. Don't get those two confused. It's not raised to the negative 1 power. It's just a way of denoting that that's an inverse function. The easiest thing when you're dealing with inverses is to think of the fact that they undo each other. So if addition is your function, then undoing addition is done by subtracting. If squaring is your function, then it's undone by taking the square root of the function. Okay, so it gets you back to square one. These two statements are very important. If you take the composite function of a function and its inverse, you'll get back to where you started. Because again, they undo each other. If you take the inverse of the function, again, you'll end up back at the start. One of the things we're going to be doing is verifying that two functions are inverses of each other. You need to check both of these. You need to put the inverse into the function, but you also need to put the function into the inverse. This other bit down here is really important. Most people are okay finding domains of functions. You know, what are the possible x values? What can I put into this function machine? People struggle with the range. Well, what's it going to spit out? With inverses, it's really easy. What you need to remember is that the domain of the function is the same as the range of the inverse, and the range of the function is the same as the domain of the inverse. So finding the range is something that you struggle with. Find the domain of the inverse, and it's the same thing. Okay, we good?
No.
How about now?
No.
Okay. What about now?
No.
Okay. Yeah, we're good? Okay.
Yeah, I'm good.
Oh, good.
I just found something I wanted to add.
I'm sorry.
In the bottom corner.
There's nothing in the bottom corner.
Yeah, there is.
Oh, that bottom corner.
I want that. Are you
Is
serious?
there supposed to be an
I
easy
actually
in
am
that?
sorry.
You just messed up.
I want that.
I was just
Okay.
wondering.
There is,
Thank
yeah.
you.
Okay, sorry.
Apologize.
But I can fix it.
You know everything about it.
Okay, so here's two functions. Verifying that they're inverse functions. In other words, I'm telling you, hey, these are two inverse functions. We want to verify that that is in fact true. In other words, prove that it's true. And I don't remember if yeah. So we're going to do, instead of having the notation, I didn't do anything yet. Okay?
Wait, you guys are.
Did I skip? We're still going.
Yeah, we're just building.
Oh, wait, I didn't do the work. Sorry. There we go. My bad. I'm out of practice. All right, we'll just do the work here. That'll be easier. I need to verify that f of g of x is equal to x, and I need to verify that g of f of x is equal to x. If they both work, then that verifies that they're inverses of each other. Okay, so let's do this first one. We'll use blue for that. What is f of g of x? How do I find f of g of x?
Plugins. G of x.
Every time there's an X in there.
Say it again, Jake.
Every time there's an F in X. Plug in G of X.
Correct. So I come here 2 times this mess, the cubic root of x plus 1 over 2 cubed minus 1. And this kind of becomes silly because you'll see that they start to undo each other. So when I take the cube of a cubic root, I get back to the original. Of course, first of the year, the pen's going to act up. Come on now.
It's all gonna show up. It's all gonna show up at once.
So as you can clearly see,
They are inverses of each other.
the cube is going to undo the cubic root. The 2 on the top, or the 2 on the outside is going to cancel with the 2 on the bottom. 1 minus 1 is 0, so we're going to be left with x, not just a dot. Let's try that again. There it is. So, somehow I worked this frowny face in there.
And an E.
Where's the E? Oh yeah, there's an E.
Equals X.
Yeah. So, but then again, what's most important is here at the end. It equals x. So, that's all we're really looking for. Oh, I hate my life. G of f of x. Go to g of x wherever you see an x. Put in this mess. So I get the cubic root of 2x cubed minus 1 plus 1 divided by 2. Okay, so negative 1 plus 1, that goes away. The 2's cancel. The cubic root of x cubed is just x, and we verified we're done. That was a pretty major pen malfunction. Yeah, we did that already. So this starts to get us going on this whole geometric approach. You may not have ever been taught this, or you may not have remembered it from pre-calc, but inverses, a function and its inverse, are reflections of each other over the line y equals x. So y equals x is that line that runs at 45 degrees through the first and third quadrant. And if we take this function here, this f of x, its inverse will be the reflection of that function over that line. Okay. That's important because that's what we're going to use later on when we start looking at taking a derivative using a geometric approach. The other thing to remember is if any point on the function that we list as AB, when you flip it over that line, the new point becomes BA. In other words, the x and the y coordinates switch. For instance, if we take the point 3, let me write this down because that needs to go away so we don't remember it ever again. On the function 3 comma 27 times 2 is 54 is 53 is on the original function, then on the inverse function would be the point 53, 3. So again, the x and y coordinates switch places. All right. That. Nope. Yes? Okay. Horizontal line test. We have the vertical line test already. What's the vertical line test do? Tells you if it's a function. I'm assuming you can read, but the horizontal line test will tell you whether or not a function, whether or not the inverse of a function is also a function. In simplistic terms, does the function have an inverse? Okay, so vertical line test tells you whether or not it's a function. Horizontal line test tells you whether or not it has an inverse. And again, you should have known this from pre-calculus already. If any horizontal line hits the function in more than one spot, then it does not pass the horizontal line test, and it doesn't have an inverse. You can still get a graph. You'll still get a picture of something. It just won't be a function. Okay, so you think about this guy, this U-looking thing. If I flip that over, it's going to look like, what's the way it's going to point? It's going to point this way. and it won't pass the horizontal, it won't pass the vertical line test. So here's the fancy calculus speak for the horizontal line test. What does 1 to 1 mean? Say again. 1x and 1y. For every x, there's one and only one y. For every y, there's one and only one x. Anything in that little boxed area that bothers you? No? You sure?
What's monotonic?
Good question. You should be bothered by the term strictly monotonic. If you're not, then you either didn't read it or you're really, really smart. Anybody have a clue?
One something.
Very strict one.
One
Stems.
something's, oh, mono,
Mono.
one.
Yeah.
Yeah, tonic. No, strictly you're okay with.
Yeah.
Gotta be, strictly. Gotta be one tonic something. Right. Strictly monotonic means it's either always increasing or always decreasing. I don't know how the one works into that.
Because it only has
One,
option.
one option, okay.
But then, what's the point of strict?
Totally beat you to it.
Let's stop talking.
I don't know if that's a good question, Todd. I don't know if there's a difference between monotonic and strictly
Yeah,
monotonic.
because if
Right,
the
I'm a
mono is
vegetarian or I'm strictly vegetarian. I don't know the difference.
They want us to learn fancy.
Anybody a vegetarian? Are you a vegan or a vegetarian? I don't mean to put you on the spot. Are you strictly vegetarian?
Well, I'm strictly vegetarian, but I don't eat fish.
Do you eat cheese?
Not really.
Okay, so are you a vegetarian because of a health thing or because of a moral decision?
More so health, and I
Health.
also just really hate the taste of meat.
Yeah, because after you haven't eaten it for a while, it disgusts you. Like you couldn't probably have a burger right now without getting sick. So you do or don't eat fish?
I don't eat fish.
What about eggs?
Not unless it's baked into something.
Okay, cheese. I don't remember what you said about cheese.
Not really.
Okay, all right. So you're not strictly a vegetarian, and I never remember the difference between vegetarian and. Do you know the difference between vegetarian and vegan?
Vegetarians can eat white meat, so they can eat chicken, fish,
Vegans eat nothing related to animals, like can't even have
Only
eggs.
fish you
don't eat
don't
animal milk.
eat any animal products,
Yeah.
so no milk, no eggs.
Nothing that comes from a living animal. I bet you they wear leather belts though. But
I just want to say that vegans don't eat animal products.
nothing.
I don't think they use them either. Like,
Just
if you're
grass.
like
Well, they're not
strictly
supposed to.
vegan.
Yeah,
Like,
if they're strictly vegan,
No belts.
they won't have a leather jacket or leather shoes.
Yeah.
But if they're just vegan,
Yeah.
you know,
What are they wearing?
hemp sweaters, hemp pants, denim. No animals were killed in the making of denim, as far as I know. Just plants. And probably like, I don't know what they do for a belt.
Just have like weed.
Shoelace?
A rope. Tie a rope around their waist or staple it.
They can use the.
Yeah, they could use the smartboard as a belt, as a smartboard thing as a belt. Okay. Which of these functions has an inverse? Take out your calculators. You got a new calculator? Oh, that's so, was it under the tree and
No,
everything?
it's from my house.
Huh?
It's from my house. It's under Rosie's tree.
Oh. That's so nerdy.
That's what I wanted for Christmas. Do I? I wouldn't doubt it.
Graph both of them and tell me, from looking at the graphs, which of them pass the horizontal line test
Alright.
and which of them do not.
I'm guessing. Whoa. I'm gonna guess. But I'll check it out.
Are you gonna guess yes?
No, I mean, your battery's completely dead. You didn't just get the warning?
Yes.
Did you get a warning? You just ignored it, didn't you? A couple of years ago, there was somebody that had a meltdown at the AP test, not here, I think it was at, maybe at Barrington, because they had the warning and they ignored it, and then the test started and their calculator died and they just snapped. It was like after the week of pressure from AP, they just snapped and freaked out. So, let's get
First
you
one,
that.
wait, the first one, I don't even.
Oh, this is happening now, not
Right. Alright, what'd you find?
Twice.
Tyler, A
does.
have an inverse function, B does not.
Yeah.
Okay, so it doesn't pass the vertical and horizontal line test. Okay, so there's part A. It is strictly monotonic. We don't know about its vegetarian status. Because it's always increasing. So therefore it is, or it has an inverse function. Now there's another way that you can check that. And this is the method that I'm going to try to get you to use, and that is to take a look at the derivative. When you take the derivative of the function, it can tell you about its increasing and decreasing. So I could have done this without looking at the picture. Notice that the derivative of that is 3x squared plus 1. What can you tell me about the value of that derivative function? Where are the critical numbers? Cricket, cricket. Move the -1 to the other side, divide by 3, x squared equals -1/3, therefore x is equal to nothing, correct. Has no critical numbers, which means?
No. Yes.
Which means no. Good. Excellent.
There's no points of inflection.
There's no,
No, that's the second.
that's second derivative. First derivative tells you
It's increasing if there's any max or min.
max or mins. There's no max or mins. Since there's no max or mins, it's either got to be always increasing or always decreasing. In other words, the roundabout way to get there, this function is always positive. Since that function is always positive, the function itself is always increasing and therefore good to go. Because you're going to have to be able to do something like this without having your calculator to rely on. And I recommend taking the derivative and looking at the values of the derivatives. Strictly monotonic. Part B, however, graphically doesn't pass the horizontal line test. There is such a horizontal line that passes through the function and hits in more than one spot. Okay, okay, and then looking at this. Taking the derivative of that pretty easy function, I get 3x squared minus 1. 3x squared minus 1 can be positive or negative, which means it's not strictly monotonic, which means it does not have an inverse function. Make sense? So again, graphing I think is easiest. However, if you don't have your calculator, because half of the test is non-calculator, you can always take the derivative and look at the increasing and decreasing values of the derivative. How do you find an inverse function?
First line for one.
No, that tells you whether or not it has an inverse function.
Plugging in.
This is pre-calc review.
Plugging
Plugging in,
the opposite equation function.
that's if you know what the inverse is. Suppose I just give you a function.
I don't know.
Don't you plug like the y's to the x's and stuff?
Beautiful.
Oh. Oh, you flipped that.
First of all, confirm that it has an inverse function. Okay, either using the horizontal line test or the derivative. I would recommend the derivative. That way you don't feel like you're tied to the calculator. Number 2, switch the x's into y's. Wherever there's an x, make it a y. Wherever there's a y, make it an x. So instead of your function being y equals 2x plus 1, it becomes x equals 2y plus 1. Then solve for y. That thing that you get when you solve for y will be your inverse function. Sometimes step 3 is easy, sometimes it can be a little nasty, as you'll see in some of our examples. Okay, good? Yeah. as I already mentioned, that resulting function is the inverse. And you want to use the notation correctly. If I start with a function y equals blah, 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 I switch the x's and the y's, I solve for y. Don't leave it as y equals, because that's improper notation. You need to change the y to an inverse f of x. So you're denoting that you realize that the thing you just solved for is in fact the inverse. That I mentioned already, the domain and the ranges are switched. Got that already. Okay, so here we go. We want to find the inverse of that function. So y equals the square root of 2x minus 3. First step, I just turned f of x into y, because we know that those two things are equal. And we're out of here at 10 after? Okay, I want to finish this and then we'll stop and pick up where we left off tomorrow. Switch the x's into y, so this becomes x equals the square root of 2y minus 3. How do I solve for y? What's the first step? Square both sides. X squared is equal to 2y minus 3. Then what? Add 3. And divide by 2. And then, as I said, the last thing is you want to use the proper notation. Pretty easy. Yo.
What is the derivative of x? If you take the derivative and if you get answers that are
You take the derivative, and if that derivative is always positive or always negative, then it will have an inverse function.
But how do you know it's like always positive?
You have to look at the function, like that 3x squared plus 1. There's no number that you can put in there and get a negative answer out of it.
Oh,
Because
so you have to just like plug in a couple numbers.
So if you can plug in numbers that make it
in other words, or even simpler, try and solve for a critical number. If you find a critical number, then it's not strictly unfounded.
78.